We understand why the chemical reaction of aldehyde and ketone with hydroxylamine is carried out in mild acidic medium. We have the chemical reaction. You can see aldehyde is reacting with hydroxylamine in acidic medium. In this case, pH value is maintained 3 to 4. 3 to 4. And the product is what? Oxime is formed. Oxime. Keep in mind, if aldehyde is reacting with hydroxylamine, aldoxime formation takes place. Or if ketone is reacting with hydroxylamine, ketoxime is formed. Okay, now we understand why this reaction is carried out in mild acidic medium. I will explain also why this reaction cannot be carried out in a strong acidic medium. Okay, first we understand reaction taking place in acidic medium. We understand how does this reaction take place. Okay, so first I take we have aldehyde is there, RCOOH is there. Okay, and it is reacting with hydroxylamine. We have learned hydroxylamine is basic in nature. Why? Because nitrogen is having lone pair, it can easily donate electron density. Okay, and we have also learned carbonyl compounds, especially aldehyde and ketones, they undergo nucleophilic addition reaction. In this case, nucleophile will attack to the polarized carbon because it carries partial positive charge. Why? Because it is attached to highly electronegative oxygen. Oxygen being more electronegative, it pulls the electron density. As a result, oxygen carries negative charge and carbon carries positive charge. Okay, this is the reason this nitrogen supplies electron density to the partial positive carbon. Okay, now this nitrogen will directly connect to the carbon. Now you can see carbon is forming 5 bond. Since it is forming new bond, then it will break its old bond. As a result, oxygen will pull the electron density. Okay, now we have, it is R is there, this carbon is there, to this carbon one hydrogen is attached, and we have single bond, oxygen will carry negative charge. Now you can see this nitrogen will directly connect to the carbon. So we have NH2 and we have OH is there, but nitrogen will carry one positive charge because it has lost electron density. Okay, lost electron density. Always keep in mind, non-metal carrying negative charge will be in a stable state, but if it is carrying positive charge, it will be in a highly unstable state. Now you can see oxygen is carrying negative charge, somewhat in a stable state, but nitrogen carrying positive charge highly in an unstable state. This is the reason it starts pulling electron density from hydrogen. Okay, so that it can remove its positive charge. So what happens exactly? One hydrogen is attached, it pulls electron density from hydrogen because nitrogen is more electronegative than hydrogen. From here, hydrogen will be liberated as H plus, and this H plus will be invited by O minus, will be attracted by O minus. Now you can see nitrogen positive charge will remove because it has pulled the electron density. From here we get, this is R is there, C and O minus, and this is H plus will make hydroxyl group. To the carbon we have one hydrogen, this side we have an H, and we get OH is there. Now pay attention carefully. Need some more space? Okay. Now in this case you can see we have two hydroxyl group. If we have a compound in which to the same element two hydroxyl group are attached, in this case we can remove water molecule, but in this case two hydroxyl group are attached to different elements. That's why water molecule cannot be removed. Another point we have also learned, OH group is a poor leaving group, it is not a better leaving group, it cannot be easily removed. But if we protonate, so it can be easily removed. So that's why to remove hydroxyl group we need a proton, and proton we can get from acid. Okay, proton we can get from acid. This is the place from here we start carrying out the reaction in mild acidic medium. Okay, from the mild acidic medium we get proton. Okay, we have the arrow mark, pH value we maintain 3 to 4. From here we get mild acid, it will liberate H plus ion is there. Now you can see oxygen is having two lone pair, it will supply electron density to the proton H plus ion. As a result, what happens exactly? You can see we have R is there and it is C is there, and this is oxygen. One hydrogen already there, but it is forming another bond with next hydrogen, but since it is losing electron density, it will carry positive charge. Okay, To this carbon, one hydrogen is also attached. Now next, we have NH and we have OH is there. Now you can see it is a better leaving group. Okay, keep in mind this is the step. From here we start the reaction in acidic medium. Oxygen having positive charge, highly unstable, so that's why it being more electronegative from carbon pulls the electron density. From here we remove water molecule. Okay, it is removed. But now carbon is losing electron density, it will carry positive charge. One hydrogen is attached, and the other side we have nitrogen, H is there, and we have OH is there. Keep in mind this nitrogen is having lone pair. This lone pair electron density will have tendency to move towards a positive charge due to the attraction. So what happens exactly? This lone pair electron density will move towards a positive charge. So it will create a double bond. Okay, so we have R, it is CH is there, double bond, and nitrogen, it is H is there, we have OH is there. Now since nitrogen is losing electron pair, it will carry positive charge. It will carry positive charge. Nitrogen in highly unstable state. So as a result, nitrogen pulls electron density from hydrogen. From here H plus ion is liberated. As a result, we get RC and it is H is there, double bond, it is N and it is OH is there. This is what we have oxygen. This is the final product we have. You can see from here we H plus ion is liberated. Now you can see whatever the H plus ion we had taken here, same H plus ion is liberated here also. Means we can say this chemical reaction, a reaction of aldehyde, a ketone with hydroxylamine is catalyzed in acidic medium. Catalyzed in the sense whatever the H plus ion we had taken, it is not consumed in the reaction. It accelerates the chemical reaction. In the end, we get the same H plus ion. We can also say this chemical reaction is catalyzed by acid. Okay, and reaction taking place in mild acidic medium. Now question arises here, why we cannot carry out this chemical reaction in a strong acidic medium? Let me explain. Let's say we have the carbonyl compound, this is RCOO and it is H is there, and we have hydroxylamine which is a better base, lone pair is there, hydroxyl group is also there, better base is there. But if I carry out, let's say having a strong acid, pH value is very small. So in this case what will happen, it is a better base and it is a better acid, they will start reacting together. Acid base reaction will start taking place. So instead of reacting with carbonyl compound, hydroxylamine will start reacting with strong acid. They will start reacting together. We have one moment. They will start reacting together and convert into salt. So now you can see this reaction will not be taking place in forward direction. Why? Because they will neutralize themselves. So their significance will be lost. So hence we can say this reaction does not take place in a strong acidic medium. It takes place only in mild acidic medium. pH value is what? pH value 3 to 4. If you like this video, please share and subscribe to the channel.